Okay, well, this matrix is easily invertible, just a 2 by 2 matrix. We don't have to go to a big row reduction process with the identity matrix and so forth. But if it was a bigger matrix, we could. Okay, so this extends to higher order equations. It's just that it's a little more complicated to find the inverse, but here, if we remember, we can just write it down. If we don't remember, well, we can kind of get it by trial and error. Okay? Otherwise, we just go to the usual process we use in linear algebra. Okay, that's always available if you're refreshed on linear algebra, right? Okay? And having only had the one course, you know, I don't expect you to be refreshed on it when you walk in here. Still, you want to refresh it, okay? So anyhow, this is the inverse. So provided I've written this down correctly, of course, the Wronskian is just the determinant of the original matrix. That's y1, y2 prime minus y2, y1 prime. Times this matrix, okay? Again, we can verify that this is the inverse and catch me in an error if I happen to be wrong and fix it, okay? But if I multiply this by this, first row times the first column is just equal to the Wronskian. And the second row times the second column is, again, just equal to the Wronskian, okay? And you can easily verify that. And then the first row times the second column is 0. You can see that. Yeah, y2 prime, y2 minus y2, y2 prime, right? And similarly with the second row, you're going to get negative y1 prime, y1 plus y1 prime, y1. So you're going to get zeros here, and you're going to get just this in these two positions when you multiply out the two matrices. And it's going to work out, because of course when you divide by this, then you end up with the 1, 0, 0, 1, your identity matrix. So you should do that, just to refresh yourself a little bit. It's very easy. So, what do we get? We get U1, U2 equals, I should have put the reciprocal of the Wronskian here, so I don't have to write another step. It's 1 over y1, y2 prime minus y2, y1 prime times your y2 prime, negative y2, negative y1 prime, y1 times 0 to your t column vector, right? Okay, well, and that's not u1, u2, it's u1 prime, u2 prime, and this should be u1 prime, u2 prime. Because, of course, our equations are not in u1 and u2, they're in u1 prime and u2 prime. Okay? So I wrote those down carelessly, which is getting to be characteristic, but there it is correct. Okay? So, u1 prime equals what? u2 prime equals what?